Hola, amigos. Here we are in the last lesson of rational expressions and equations. This one's about the applications or word problems. The number one application of rational expressions and equations is about rates. And so when I'm saying a rate, like think when I'm driving my car down the Deerfoot and I'm clearly only going 100 kilometers an hour, right? I would never go 101. That's my rate. So what does it mean to be a rate? Well, a rate means it's a ratio. It's something divided by something, right? So that's my distance over my time is equal to my speed. Okay, so a rate, it's a ratio. We're comparing two things. So let's look at these things. All right, what do we got? We've got Stella takes 4 hours to paint her room, takes Jose 3 hours to paint the same area. How long will it take if they actually work together? All right, operation cooperation. They're going to work together. Okay, this is all about rates. What's Stella's rate? Well, Stella says she takes 4 hours to paint a room. So one room in 4 hours. Okay, Jose here, what's their rate? One room in 3 hours. Okay, so that's their individual rates. Now, what about if they did it together? Okay, well, if they're working together, we hope, as long as they're getting along, that it's going to go faster, right? Not always the case. Well, what's their new rate? Well, again, now it's going to be they're still painting one room, but I don't know how many hours. So let's call X the number of hours it's going to take for them to paint that room. There it is. I've set up my equation. And sometimes just setting up that equation is the most complicated part. All right, here we go. This one's not going to be too bad. Let's get a common denominator here. Well, factor, nothing to factor. NPVs, yeah, X can't be zero, right? That makes sense, right? Can't paint something in 0 time. I wish we could. This painting sucks. I hate painting. It's the worst. Okay, I'm going to get a common denominator. So my common denominator is 12. And 12x, I should say, like that. Okay, and now what do I have? Well, left-hand side is equal to the right-hand side. Denominators are equal. Therefore, the numerators are equal. Simplify. 7x is equal to 12. And x is equal to 12 over 7. So it's going to take them, what's that? Just under 2 hours to paint the room. And, so I'm going to say, write a sentence, right? It takes them 12 over 7 hours. And maybe in the question it says to round, right? But 12 over 7 hours to paint the room. Okay, so it never hurts to write a sentence at the end, right? Okay, again, I could check my work by subbing in 12 over 7 back into my original equation. Now, I do want to talk about one more thing. Okay, yes, I know x can't be 0 because I can't take me 0 time to paint a room. But the other thing is I just want to think about this. If like maybe I should have called that t for time, right? Because it's time. But what do I know here? I know x has to be greater than 0 because it has to take me more than at least 1 second to paint this room. Okay, this is called my restriction, right? It has to take me more than 0 seconds to paint the room. So that's something maybe I want to consider as I'm doing these questions. Okay, so this type of question here where it's a couple people working together to do something, you'll see a lot of that in the textbook. I think kind of the more famous question is something like this. Okay, so who do we got? We got Penny and Raj. Okay, what's that? That's the Big Bang Theory, I think, right? So Penny's driving 15 kilometers faster than Raj. She can travel 180 kilometers an hour in the same amount of time that Raj can travel. Let's find their speeds. Okay, this is a very, very common question. If you end up taking 30-2, like this is like a diploma question almost. Okay, how I'm going to set this up is I'm going to set up a chart. Distance, speed, time, like that. Okay, And who do I got? I've got Penny and I've got Raj. All right, so set up my little chart here and I start filling in my info. That's a pretty looking chart. Look at that. Okay, what do I know? Okay, it says Penny drives 15 kilometers an hour faster than Raj. So I don't know how fast Raj is driving. So I'm going to say let X be Raj's speed. What I know is Penny is driving 15 kilometers an hour faster, like that. She can travel 180 kilometers in the same amount of time that he can travel 135 kilometers, just like that. Okay, time. So when you're filling out this chart, you're always going to be able to fill in the first 4 boxes. It's the last 2 for time where our work is going to come from. Time is distance divided by speed. Time is distance divided by speed. So Penny's time is 180 divided by x plus 15. Raj's speed is 130 divided by x. Now, like I said, my equation, what I'm going to work with, is always going to come from time right here. So there's usually a piece up in the question that we need. It says she can travel this in the same amount of time. So what does that tell me about 180 over x plus 15 and 135 over x? Well, simply tells me this. Tells me those 2 things are equal in the same amount of time. They're equal. Okay. Now, wouldn't hurt to maybe write down my NPVs here. Again, x can't be 0 and x can't be negative 15. That makes sense again, right? Their speed can't be 0 because they're going somewhere, and their speed can't be negative 15. Doesn't make sense. Now we got that. In fact, my restriction, well, x has to be greater than 0 because it's some sort of speed, right? So that's my restriction. Hey, nothing to factor. That's easy. I'm going to get a common denominator. My common denominator is x plus 15. So I like to write it like that. And now that I've got myself a common denominator, I'm good to go. I'm going to, left-hand side is equal to the right-hand side. So the numerator is equal to the denominator. And now all we've got to do is just solve this thing. Okay, what do we get? We get 180x is equal to 135x plus, oh geez, 135 plus times 15. I'm going to grab my calculator out because it's way too early in the morning. I don't feel like doing that in my head. 2025. Okay, solve for x. So I'm going to subtract 135 from both sides. That sounds like 45 to me. And now I'm going to divide both sides by 45. And what do I get? I get 45. Okay. So what I'll see here is I'll see a lot of people just stop and say, okay, x is 45. No, well, did you answer the question? Let's go back. What did the question ask me? It asked me, what are their speeds? Okay, x is Raj's speed. So let's answer the question. Raj's speed is 45 kilometers per hour. Penny's speed is 45, x plus 15, 45 plus 15 is 60 kilometers an hour. Okay, so they're clearly not on the Deerfoot. If they are, they better get off. They're going too slow. Okay, again, how do I check my work? Well, if I wanted to, I just come back up into here. Okay, so if I sub 45 into both sides of this equation here, I'm even going to do it. Okay, let's go for ugly green here. Okay, if I sub in 45, what do I get? 45 plus 15 is 60. On the left-hand side, I get 3. What do I get on the right-hand side? I sub in 45. 135 divided by 45, and guess what that is? That's 3. Done. I did the question correctly. So those are kind of your 2 major types of questions. distance, speed, time, when you go to set it up, you will know all of these four boxes generally. Then your equation will come from time. You'll have to look back up in the context of the question and say, okay, what else do they tell me about the time? And then make the equation from there. There it is, amigos. Rational word problems.